Alright, complete printed circuit board designing using Orcad capture and layout. Craig Mitzner. Nunes Publisher. Complete PCB design using Orcad capture and layout. Craig Mitzner. Nunes Elsevier. Copyright 2007. Elsevier Incorporated. Table of contents, introduction, acknowledgement, introduction to PCB design and CAD, computer-aided design, Orcad design suite, printed circuit board fabrication, printed circuit board cores, layer and stack up, printed circuit board fabrication process, photolithography, chemical etching, mechanical milling, layer registration, function Orcad, layout, PCB design process, layout, formats, .max, post-process, GURB files, PCB assemble layers and files, introduction to PCB design flow and example, overview, design flow, creating circuit, designing with capture, starting a new project, placing parts, wiring, connecting the parts, creating layout, net list, and capture, designing printed circuit board and with layout, starting layout, importing the net list, making a board outline, placing the parts, out routing the board, manual routing, cleanup, locking traces, performing design rule check, processing the board design for manufacture. Chapter 3. Project structures, layout, tool set, project setup, schematic, entry details, capture projects explained, capture part libraries explained, understand layout, environmental tool set, board technology files, auto, eco utility, the session frame, design window, the toolbar, controlling the auto router, processing layer details. Chapter 4, introduction, industry standards, introduction to standard organization, Institute for Principal Circuits, IPC associating connecting electronics industry, Electronic Industry Alliance, EAI, Joint Electrical Device Engineering Council, GEDEC, International Engineer Consortium, IEC, Military Standards, American National Standard Institute, ANSI, Institute of Electrical Electronic Engineers, IEE, class types, printed circuit boards, performance class, producibility level, the fabrication type, assembly subclasses, Orcad layout, design complexity, IPC, Institute of Printed Circuit Board, performance class, Institute Printed Circuit Board, land pattern, density level, introduction, standard fabrication allowances, registration tolerance, breakout, annular ring control, PCB dimension tolerance and standard panel size, tooling for our allowances effective with the panel usage, standard finished printed circuit board thickness, core thickness, pre-preg thickness, copper thickness for the PTHs and Vivos, copper cladding foil thickness, copper tracing, etch tolerances, standard hole dimensions, solder mass tolerance, end note, suggested reading other items of interest. Chapter 5, Introduction Design for Manufacturing, Introduction Printed Circuit Board, Assembly Soldering Process, Manual Assembly Process, Automated Assembly Processes, Pick and Place, Soldering Processes, Manual Soldering, Wave Soldering, Reflow Soldering, Component Placement, Orientation Guide, Component Spacing Through Hole Devices, Discrete THDs, Integrated Circuit Through Hole Devices, Missed Discrete IC Through Hole Devices, Hole Jumper and Wires, Component Spacing Surface Mounted Devices, Discrete Surface Mounted Devices, Integrated Circuit Surface Mounted Devices, Missed Discrete Integrated Circuit Surface Mounted Devices, Mixed THD and Surface Mounted Devices, Through Hole Devices and Surface Mounted Devices, Requirements, Footprint, Pad Stacks, Design for Printed Circuit Board Manufacturability, Land Patterns for Surface Mounted Devices, Pad Stack Design and Foot Design, Land Patterns, Through Hole Device, Footprint Design for Through Hole Device, Pad Stack Design for Through Hole Device, Hole to Lead Ratio, PTH land, dimension, annular ring width, clearance between plane layers and PTH, solid mass, soldered mass, solid paste dimensions, PCB design for single integrity circuit design, issues not related to PCB layout, noise distortion frequency response, issue related PCB layout, electromagnetic interference crosstalk, magnetic fields, inductive coupling, loop inductancy, Electrical fields, capacitive, the coupling, ground panels, ground planes, ground pounds, what is ground, what is not ground, return plates, ground bounce, rail collapses, split power ground planes, PCB electrical characteristics, impedance, reflections, ringing, electrical long traces, critical length, transmission line, termination, PCB routing topics, parts placement, electrical consideration, PCB layer stack up, bypass, capacitor, ramp, fan out, trace width, carrying capability, trace width, controlled impedance, trace spacing, voltage withstanding, trace spacing, minimizing crosstalk, 3W rule, traces with acute or 90-degree angles, making editing, capture part with capture part libraries, type of the packaging, homogeneous, heterogeneous parts, pin, part editing, select tool settings, pin tools, graphic tools, zoom tools, construction construction capture parts. Method 1, construction parts, you have the new part or option, design menu, design example, passive, homogeneous part, design example, inactive, multi-part, homogeneous component, assigning power pin, visibility, design example, the passive and heterogeneous part. Method 2, constructing parts with the capture using the design spreadsheet. Method 3, constructing parts using generated parts from tools menu. Method 4, generating parts with a P-Slice models editor, generating capture part library with a P-Slice model library. Making and obtaining P-Slice libraries for making new capture parts, downloading libraries and models off from the internet, making P-Slice models from captured project, adding P-Slice templates models to pre-existing capture parts, construction capture symbols, making editing layout footprints, introduction library manager, introduction layout footprint library, naming conventions, layout footprint libraries, name conventions, composition footprints, pad stacks, obstacles, text, datum, insertion, origins, basic footprint design process, working pad stack, accessing existing pad stacks, even adding pad stacks properties from the spreadsheet, saving footprints and pad stacks, footprint design examples, design example 1, surface bounded footprint design example 2, modified through the whole footprint and design, using pad array generator, introduction, foot design PGA or foot design PGA, blind buried microvasive, amount of holes, printing catalog at foot library. Chapter 9, PCB design examples, overview of the design flow, example 1, dual power supply, analog design, initial design concept preparation project, set up the design capture, defining board requirements, importing design into layout, setting up the board, pre-routing the board, auto-routing the board, finalizing the design, mixed analog dialogue digit design using split power ground planes, mixed signal circuit design and capture and power grounded connections into digital analog parts, connecting separate analog digital grounds to split plane, using buses for digital nets, defining layer stack up with the split planes, establishing primary power plane, creating a split ground planes, creating nested power planes with copper pores, using anti-copper plane layers, setting up running an auto router, moving routed trace to different layer, adding ground planes, guarded traces to routing layer, define views, flood planes and pores, setting copper pore spacing, switching ground plane manually, using anti-copper obstacles of the copper pores, routing guard traces and rings. Example 3, multi-page, multi-power, multi-grounded mix AD, PCB design with P-Slice, project setup P-Slice simulation and layout, adding schematic pages to the design, using off-page connectors with wires, using off-page connectors with buses, setting up multiple ground systems, setting up P-Slice sources, performing P-Slice simulations, performing simulated project layout, assigning the new technology file, placing the parts on the bottom of the back of the board, layers stack up with a multi-ground system, net layer assignment, through-hole blind Viva setup, fanning out over the board, multi-Viva overriding known errors in layout, auto-routing with DRC root box, using force thermals to connect ground planes, using auto-eco to update the board from the capture, example 4, high-speed digital design, layer setup, micro-strip transmission lines, Viva the design, heat spread for the construction, heat spread with the copper area of the obstacles, using free Viva as heat pipes, determining critical trace length with the transmission lines, routing controlled impedance traces, mounted ground areas for the clock circuits, routed curved traces, the 8 pin swapping, switch stitching, a ground plane with free Viva the matrix, miscellaneous items, fixed back, Pad X's design cache cleanup replace update, adding test points, types auto ecos, making custom capture template, making custom layout technology template file, using StackUp Editor, using StackUp Editor with the active board design, using StackUp Editor to set up the custom technology or template file, submitting StackUp drawings with Gerber files, adding solder thieves, printing a footprint catalog for the PCB design. Chapter 10, Post-Processing Board Fabrication, Circuit Design with Orcad, Schematic Design Capture of the board design with layout, Post-Processing Design with layout, fabricating the board, choosing a board house, setting up a user account, submitting Gerber files and requesting a quote, anointing the layers and types of StackUp, receipt inspection and testing non-standard Gerber files. Chapter 11, Additional Tools, using P-Slice simulated to the transmission line, simulating digital transmission line, simulating analog signals, using Microsoft Excel with a bill of materials generated with a capture, using Spectra Auto Router with the layout, introducing Gerber tool, opening layout, and generating Gerber file with the Gerber tool, making a .drl file for a CNC machine panelizing, using an IPC 735 one land pattern viewer, and using CAD tools of 3 modeling a PCB. Appendixes, layout, technology, list of design, partial list of packages and footprints, some footprints including Orcad layout. Appendix D, rise and fall times of the various logical families. Appendix E, drill and screw dimensions, and Appendix F, reference by subject. Bibliography and index and reference and index. Chapter 1, Introduction to PCB Design and CAD.